All right, good afternoon, everybody. Hopefully you just had a great time with the first geomorphology lecture exam, and everything went well. Because of the exam and what might have taken people different amounts of time in order to complete it, it was going to be difficult for me to try to push, of course, the lab exercise right after today. So what I decided to do was, since most of this work can be done out of class, just to kind of make a video, put some stuff together, put it on the eCompanion site where you can go download it. You're going to need your notebook, you're going to need Google Earth and other things in order to complete this exercise. But this just seemed to be the best approach. You can't afford not to do something this week because we've already lost 1 week of lab, and we will lose another one. We'll not lose it, but it's going to be transferred out into the field when we do the field trip. So anyways, moving forward. All right, this is lab exercise 6, and it's going to be relative to volcanic volcanic landforms and how to derive indices. One of the things that geomorphologists want to do today is try to quantitate the world in one form or another. And although this isn't really a quantitative evaluation on anything to do with geomorphic process, we'll at least get at a possible set of geomorphic indices for classifications of these landforms. Now, there are numerous landforms which we'll learn about starting on Wednesday in lecture, but relative to volcanic systems. But for the purposes of this lab, I'm going to concentrate on the three that you're most familiar with, and that would be shield volcanoes, stratovolcanoes, and cinder cones. We're not going to do anything with lava domes of Mars or calderas or other things we'll be learning about, like I said, here on Wednesday. So without further ado, moving right along, the objectives of this lab are basically to allow you to start to compile some data. But more than just compiling some basic data and doing some calculations and then doing a simple evaluation of what this might mean. Again, we're going to try to take it to one level further, where you're going to not only just say, well, it looks like slope might separate these things or something else, but we're going to try to formalize these things and show why that might be the case, because you'll be doing some simple statistics as part of this whole exercise as well. Although this first part of this exercise is going to basically focus on the data compilation stage. One thing I'll add right now, you will be able to work in groups in this. In other words, I don't expect each and every one of you to go collect the data for all 66 volcanic systems that we've identified here, because you do have to go in and enter those coordinates into Google Earth and search a few different pieces of information based on what you can extract from Google Earth, compile it in the Excel spreadsheet, which I've set up for you, and then, like I said, in another video I'll show you how to add some things to that spreadsheet and then do some basic statistical calculations and kind of get look at a couple different ways we can evaluate that data on a more formal level than you might have done in the past. Okay, so that's basically what, again, this whole exercise is going to be about. The other thing I'm going to want you to do is, once you've gotten the data compiled for a volcano that you're working on, I'm going to want you to zoom out, identify exactly where that is on the face of the Earth, and then establish the tectonic setting. Okay, and then we'll talk about the significance of that later, but that'll be another goal of this. And I provide you a place on the Excel spreadsheet in which to enter that data. What you're going to need for this is your notebook computer or access to some other computer that basically has two things on it: Microsoft Excel and Google Earth. Okay, I will provide you with the Excel spreadsheet that's already been set up with the name of the volcano, its latitude and longitude coordinates, so you can go in and get to that location quickly, and then I'll show you through this video or another short video that will follow this exactly how to go in and extract the data that you need. Once you extract that data, you'll enter it into the appropriate row and column, the cell in the spreadsheet, and after you finish your compilation, we'll be able to move forward with the next phase of the data analysis. Okay? And the other thing I'm going to provide you is the video tutorial guides, this being one of them. And I don't know how long going to let this go. It's already at 5 minutes, so I may cut this short real quickly after I just show you the tools you've got, and then I'll come back and do something relative to the formalities of actually going in and collecting the data. Okay, so that's a basic intro of what you're doing. You're going to be expected to go in and again using some basic information I'm going to provide you as far as the latitude and longitude of different volcanoes. Get to those locations in Google Earth, then extract the maximum height of the volcano at the top of the cone, at the edge of the crater, the base, the elevation at the base of the volcanic system, the distance between those points that allow you to calculate slope. And then the other thing I don't want you to get is the diameter of the volcanic system. But again, I'll show you the specifics how to do that in Google Earth here in a few moments. Okay. So here's a look at the spreadsheet, and basically starting out at the top, and this is what I'm going to provide to you. We have the name of the volcanic system, the type of volcanic system it is. Kilauea is a shield volcano. I have a blank space here, which you will fill in the tectonic setting. Well, for Kilauea, obviously, I think you know what that is, hotspot. I'm giving you the latitude and longitude, which one of your classmates, my office person this semester, has gone in and already compiled this stuff. So you're going to be double checking his work. I spot checked it. It looked okay to me. Hopefully there's no errors. Then the other thing we're going to have to go in and do, and I'll scroll across the spreadsheet here. You're going to get the maximum elevation, basically at the edge of the crater, at the crest of the volcano. The base elevation of the volcano, so down at the bottom of the slope. You're going to have to use the distance function in Google Earth to then calculate the distance between those points. As you're collecting the data, you will need to be making sure that you have everything set in Google Earth to collect things in meters and kilometers. Since the distances are better calculated in kilometers, there's going to have to be a simple conversion to calculate things back into meters, because when we calculate the slope, we'll want to do things in like terms just so we get a meaningful fractional value. Now, these are not the maximum elevations in base elevation and distance or height and so forth for Kilauea volcano. It's much larger than this. I just plug these numbers in. Everything else is set at zeros because I have some formulas in here, so it wasn't showing some screwy stuff initially. No, but in this case, if this volcanic system happened to have a maximum elevation of 500 feet, a base elevation down at the bottom of its slope of 250, meters, not feet, 500 meters and 250 meters. If the distance between those points, the maximum elevation and the base elevation, was a half a kilometer, you can go in and start to calculate slope. How do we do this? Well, the height, the rise, calculating slope here, is the difference between this value and this value. Well, in Excel, this cell isn't that value. It actually has a little formula up here where it says that it's going to subtract the value in cell F2, this is column F, row 2, that's it, from G2, to get the difference, 500. We switch over to slope. I've already got the formulas in there for you again. So the result you get for I2, which is the rise, the height the height of the volcano from the base to the max point, is going to be divided by the distance between those points, which is in kilometers, so it has to be converted into meters. That's what's going on down here. The value in H2 times 1,000 is then divided from this value here to get the slope, which in this example case is 0.5. Again, this is not the data for Kilauea. You're going to have to do something else. Okay. Then we're going to have to go into Google Earth, enter the latitude and longitude coordinates into the query box, the fly to box, and then once you enter that, it'll zoom into the area. And like I said, I'm going to show you formally what goes on here, but since I want to get these things onto YouTube to make it accessible, I'm getting it 10 minutes. I'm going to cut this short now. So I'll pick up with what to do with Google Earth here and how to enter the data in a moment. Be back soon.